All right, welcome back everyone. Welcome to Calculus 3. So in this video, we are going to talk about 5.2 double integrals over general region. So last time I introduced the double integral, when you have two variables of the function. So we're going to keep on doing the similar work to find out the region if you have two different ranges of the two variables of the function. So let me show you the definition of the double integral. Actually, we learned how to do it, but let me just show you one more time. So just briefly, in Calculus 2, we've been utilizing only one single integral. So for single integrals, the region over which we integrated is always an interval x and b. So what I'm saying is, you had f integral, let's say we have a function dx, and then this a and b implies that it's the range on the x-axis, so that you're taking the integral with respect to only x variable. But now we are talking about double integral, which means you have to take the integral with respect to x and y both, so that you are going to have two different range. One is for the x variable, another one is for y variable. And then based on that information, we are going to find out the region or volume or a lot of other information, right? So here is the thing. I'm going to show you two different types of the double integral. One is focusing on the x variable, and then another one we're going to focus on y variable, just different order because we have two different integral. So here we're going to talk about the first type. So let me highlight it. So the goal is the same thing, right? So we have, this is a Calculus 2, one area from A to B, but we have two, functions going on, and then you have two different, ranges. One is for AB on the x-axis, and then another one is on the y-axis, right? So if we have like a straight line, this is so easy to find out the region, but not always you're going to find out this clear linear equation for the function. So sometimes you might have a curve. So that's a little bit tricky to define the range on the y-axis, right? Because this is not really straight line, right? You have a curve going there. So in this case, the y height will be described as a function. So as you see that, this is going to be range from G1 and G2. This indicates that your function is not going to be straight line. It's something, curvy. It's a little bit difficult to measure by a ruler. So therefore, it is written by a function, because a function is always helping us to find out different height based on different x-axis. So therefore, in this graph, we are trying to find out this region. But as you see that, we have two variable going on. And then you have a different range for each x and y axis. So A and B, this is clear for the dx. So this is an outside relationship. And then you have a dy, this is inside. And as you see that the y height is not really, linear, so that it's going to be written by the function. So this is a double integral, one of the type. Same thing, if you have like y is always complicated if you look at that, because x interval is so clear. From A to B, you can cover entire region, but from like here to here, you have a lot of errors going on. So if your y variable, it's a little bit curvy shape, then you need to find out the given function that is represented by the different height of the on the y-axis. So I'm just showing you a variety of cases. You might have this type of region where A, B is fixed. These are fixed on the x-axis, but the y-axis height is changing. Then your interval for the y-axis must be between it's going to be the function. So this is the type 1, where x is fixed, but y interval is going to be changing depending on the x variable. So this is a type 1. So just remember, as you see that, there will be type 2. It's going to be opposite. So what is a type 2? Your y-axis range is a fixed. So C and D, this is a fixed. But when I look at the A and B, right, this is not the straight line. So there's arrows going on so that the height function should be, given. And then you need to find out, because the height is changing in terms of the x-axis, then it's going to be opposite. So the x-axis in this time, it's not the straight line. There's a curvy going on. There's a curvy going on, so that you need to find out the given function. So that's the two cases in terms of the double integral. We are focusing on the integral. So we know that if you're taking the double integral, we are looking for the answer with respect to x and y. And then for each x and y, we have a different integral going on. So one case is the x integral fixed, and then y the integral is changing. Type 2, this is a type 2. As you see, the y in this time, y is a fixed, and then h, the x integral, I'm just using the different function. It could be g, it could be whatever, but in this time I'm using h function. So for the x integral, the height is changing so that it's going to be opposite. So we have a type 1 and type 2 cases, and we're going to solve this kind of, questions, in 5.2. So this is a double integral for the general region. The key point is check the integral. Do I have x integral fixed or y integral fixed? One of them going to be fixed, because if both of them fixed, this is going to be super like a linear square. It's easy to find out without taking the integral. But we know that one of the x's is going to be curvy shape. Like as you see that for this image, y is a curvy. For the second, this image is x is a curvy, right? So therefore, you need to keep in mind, check the integral. So remember, if you have, changing integral, that should be inside. That's the rule. And then fixed is always the outside, okay? Same thing. If I have a fixed outside, right, we know that the other one is going to be changing, so that should be inside. So this is a type 1 and type 2, so I'm going to write it. For type 1, this is the case, x interval, fixed case, and then of course y is going to be changing. For the type 2, y interval fixed, so that means that x interval is changing. So therefore, y inside, x is inside. Whatever changing interval is going to be the inside. So that's the definition of double integral over general region. We're going to find out the region between two curves of two variables function, so that we need to keep in mind what's going on with the interval. Does it make sense to you? So very similar what we did in calculus 2. So we talked about, if you remember, like a rotating x-axis, y-axis, it's very similar like that. But here we are looking at the region, not the volume. So we are not rotating it, but we need to check two intervals are going on. So if you got this concept, it's not really complicated concept. I'm trying to show you the main idea so that, it's a lot of information, honestly, but you got this. So I'm going to hold up here. Okay. I'm going to show you a couple examples in applying this concept double integral with different interval. So I love to see you guys thumbs up. Maybe you're writing or jot down this concept on your notebook. So if you got that one, so just keep in mind, type 1 and type 2, they have a different fixed interval. So let's take a look at the first example. I really want to do this type of question. So here we go. So exactly, they are giving you the double integral. So we know the symbol going on, and then the R means find out the region, okay? When you have this given function, x times cosine x. So we know we are looking for the region by taking double integral. And then of course, they're dealing with the two different variables as a one function, correct? So let's just take a look at more information. They say this region, let's say it is a D, it is bounded, surrounded by y equal to 0, y equal to x a second, x equal to 2. So this information is indicating that you have different interval. we have different interval for each x and y variable. Does it make sense? Because it is a double integral. So I'm trying to find out that interval based on this information. Let's draw the image. So I'm going to draw that image. So y equal to 0, if you draw that line, it is going to be y equal to 0 is going to be the x-axis. So many people forgot y equal to 0 means like y equal to 1 horizontal line. So y equal to whatever number, it is a horizontal line. So y equal to 0 exactly x-axis. And another one is a y equal to x-axis. So this is y equal to x second. And x equal to 2. So 1, 2, we have this one. So this is x equal to 2, correct? So we are looking for the x cosine y is going to be in this function. So this is the interval that cover this region. So actually we are looking for this area. As you see that this is not the linear, this is a curvy shape. And then by taking, this integral, you will be able to find out the region that are surrounded by those 3 different intervals. So step by step, let's think about it. What is going on? So this is the image, and I'm trying to find out the region. So step 1, check which type region. So when you look at this image, the x-axis, this one, so you can see visually, x-axis is fixed from 0 to 2. Am I correct? The y is different because it's not linear, it's a curvy there. So y is going to be something given a function, or we need to find out by looking at this image. So this is going to be type 1 double integral because x interval is fixed, as you can see that. So this is so clear. This is a super linear. So x-axis is fixed. X interval is fixed. This is a type 1, and we're going to find out the region. So according to the definition, if you go up, we need to find out this region. We're going to write down this this information. So D, we have x comma y, right? And then one thing I'm 100% sure is x interval. X is between 0 and 2. Am I correct? Because it's fixed. How about the y? How can I find out the y? So y is going to be between some and something. So when you look at this, the y is going to be depending on this function, y equal to x second power, right? So definitely it's going to be start from 0 anyway. And then they're stopping at here, x second. Because it's a curvy, so it's going to be between 0, x to the second. That's the y. If x is 1, it's going to be, 1. It's 2, it's going to be 4. So this is all the variety. This is all the, different height based on the y interval. So this is what I can set it up. This is your given interval. So nothing is special. We got this. Are you following? So this is an important step to set it up, which type, double integral, and then write it, the specific interval for each x and y. Now we're going to take the double integral. Then what? We have a double integral. We are looking for that region, D. And then function is given, x times cosine y, and dA. We are looking for this information. Right now, we can adjust every interval because the interval is given now. So which one is going to be inside? Y is going to be inside. I told you fixed is going to be the outside interval. So double integral, the 0 to dx at the end, this is a fixed. And then I do have x times cosine y, dy, you're going to take the integral with respect to y first. And what is the y interval? From 0 to x second. Are you following? That's it. You're going to take this integral and you will get the simple answer. But you should understand how to set up this interval. Okay? So the x is fixed. as unit type 1, it should be outside. And then whatever the inside is going to be the changing one. So we're going to take the dy integral first. So step by step, what happened? If you take the integral inside, x times cosine y, what are you guys going to do? This is the integral with respect to dy. So x is going to be considered as a constant. Guys, keep in mind, we are taking the integral with respect to dy. So you don't need to really care about x. This is just constant. So I'm going to keep constant. So x there, and cosine y dy will be what? Sine y, right? So if you go back to the integral table, so that's going to be from 0 to x to the second. And we have another 0 to 2 at the end, dx. Are you following? So we're going to keep on going. I'm going to make it smaller. I need to smaller. So then the outside's still there, but inside, you're going to plug in x second into the y, because this is still y, respect to y variable. So x, I'm going to actually need more space, x times sine x second minus x times sine 0, and then you're taking this outcome, taking the integral, this outcome with respect to x variable. Are you okay? So this is f of x second minus f of 0. That's what I did. So let me simplify though. So this one, what do you guys think? X is 0, sine 0 is always a 0. So this is anyway 0. So we have 0 to 2, x times sine x second dx. That's the next step, the outside integral. What are you guys going to do? So we are taking the integral with respect to x second, I see everywhere x. So here, you feel like something has been subbed there. X second has been subbed there. So we're going to use a u substitution that you learn in calculus 2. So I'm going to say u equal to x to the second. Du over dx will be 2x. That means du equal to 2x times dx. So we need to find out x times dx corresponding. If you divide it by 2, it's going to be x times dx, as I divided by 2. So that means what happened? X times dx, that is going to be equal to 1 over 2 du. Are you following? So this is a u substitution. I'm not doing any special. We learned this concept, the u substitution. Then now go back. So now what happened? Integral 0 to 2. Everything is going to be written by u variable. So sine u, because x second was u. And then I have x times dx, that's going to be 1 over 2 du. So we're going to bring 1 over 2 to the front, 1 over 2, 0 to 2, sine u du. Take the integral, 1 over 2. What is the integral of the sine? Negative cosine, correct? So negative cosine u from 0 to 2. So you're actually subtract the different one. So 1 over 2 negative cosine 2. Am I correct? Oh, actually, I made a mistake. Where do I have a mistake? Because we change everything x to the u variable. So when you have x variable, the interval was 0,2. We have to also change u. So according to here, u0 is going to be 0 to second. So, and the u2 is going to be 2 to the second 4. So actually, you have to change the interval in terms of the u. So my bad. So here, because now everything is a u variable, so it's going to be 0 to 4. So they are changing from 0 to 2, 0 to 4. So you remember this. So 0 to 4, and I do have 0 to 4. Better? Yes. So now let's take a look at the final answer. So minus 1 over 2 cosine u and 0 to 4. That means negative 1 over 2 cosine 4 minus minus 1 over 2 cosine 0. So we're going to calculate that one. Cosine 0, it's going to be 1. So if you remember, go back to the decimal. You know what? I'm going to just minimize a little bit. So therefore, this cosine 4 will be, we cannot use a decimal, so I'm going to just keep using that one. But this is going to be definitely 1. So negative 1 over 2 cosine 4, double negative change of 1 over 2. So that's the answer. You can change it to decimal, but I'm going to just keep this fraction. So that's how you're taking the double integral with the two different interval that is given. Okay, so check which one is a fixed. So in this time, definitely x interval is a linear, so it's a fixed. But whatever the y is a curvy, so it's not fixed. So therefore, I use a type 1 double integral. And the rest of work is a literally calculation part with the double integral. But you guys been practicing how to take the integral since calculus 2. So I'm not worrying about that too much. But if you forgot what the u substitution, you know, just go back to the calculus 2 and check it out. All right, that's what it is. Okay, so if you got that one, I'm pretty sure you might be smiling. I'm going to practice more. Don't worry, we have a couple more. I'm always ready to bring more practice. So if you're ready, show me your, invisible thumbs up, whatever. So let's move on to example 2. So this is a double integral, right? So let's do the example 2. Here we go. I'm going to go down slowly. So the patterns are same. The function will be given, and then you need to check the interval, which one is a fixed. So here, they want you to find the volume of the solid that lies under the elliptic paraboloid. So this is the function is given. So this is the function fx comma y, that is z, 3x second plus y second. And then this volume is above the region in the xy plane, surrounded by those two information. So let's step-by-step thinking. So we have y equal to x. So if I draw the image, y equal to x is the linear. So y equal to x, so one of the interval will be fixed. And then x equal to y to the second minus 1. So this is a little bit awkward order. Usually we are saying y equal to something. We are solving for y. So what I'm going to do, I'm just trying to find out some intersection point between those two intervals. So since they say x equal to y, x equal to that, I can make it equal to each other, isn't it? So let x equal to y, or we can say, because x is a y, equal to y to the second minus 1. Does it make sense? Because we know y equal to x, y to the second minus 1 is x, they're equal. The reason why I'm trying to find out some intersection point on y-axis. So let's solve this one. What are you going to get? Let me bring y second minus 2y equal to 0. I just changed that order. So y moved to the other side, and then I'm going to find out the common factor. So what does it mean? Y equal to 0 or y minus 2 equal to 0, so that we have y can be 0 or 2. So this is where they are meeting each other. So y equal to 0, y equal to 2 here. Okay, so something going on there, something going on. So this is pretty much a given. This is pretty much a given. And then when you look at the given function, it's a parabola, right? So we have to think about it. When you look at the given information, we should think about it. The y variable, it's going to be definitely between 0 and 2. So it looks like y is a fixed. This is the fixed. This is a super linear. But then I think, something is passing through this point because this is intersection point. So if I imagine the region, something is going on like this. It's a little bit awkward shape, but because this is the parabola, okay, so it's not, there's no way you're passing through those 2 points like this way. So this is the something only way we can passing through those 2 points, and then you're stopping y equal to x. So I think this is gonna be the region we are looking for. Does it make sense? We found out the, specific points 0 to 0, 2, and then you need to passing through this point because this is intersection, and then you have to draw the line that is passing. So this is the only way I can draw. So basically we are looking for this region. Okay, so this one, what do you guys think? What do you guys think? Definitely y is a fixed, correct? From exactly y equal to 0, y equal to 2, this is a fixed. And then the x interval is a changing. It's a longer and getting shorter in terms of the x. So this is a type 2. Are you following? This is a type 2 integral. So therefore, what happened? The interval you can write y is a fixed 0 to 2 for sure, because this is a linear. And then whatever the height of the x-axis, this is the interval from here, but we have a lot of errors going on. This is a changing. As you see, the height is getting changing. So the x, we need to think about it. X is between where to where. So here we have this situation between something and something, but definitely they're stopping here and they're going to begin somewhere here, right? So how do I write that? It's actually given. X is y, x equal to y to the second minus y. So what I'm saying is y, x equal to y, x equal to y second minus 1. Let's say when x equal to 1, y will be 1. For the second function, if x equal to 1, what happened? This is going to be y second minus 1. But in this case, we need to think about it. It's always going to be less than y. So what I'm saying is we are going to compare, because of the minus, y second minus y is going to be less than 1 if x equal to 1. So what I'm saying is here, y to the second minus y is always a less than y, because this is you're stopping it. And then your y second minus y is going to be parabola. So it's going to be begin here and stop at here. So this is the right order. I know it's a little bit confused. Think about it. Okay. So I'm not changing anything. I'm just using the given information. So now we are going to take the integral, double integral. And then now x is changing, correct? So the dx will be inside. This is the given function, 3x plus y second. And then x, where? Y to the second minus y, and dy is a fixed. So you have a 0 to 2. You're taking this integral, basically. Okay, so I'm gonna try the inside first. So we are taking the integral with respect to x. Y is always considered as a constant. So this one will be 3. We are taking the integral. So 3x to the third over 3, right? And then y is a constant. You're gonna increase x and y to the second. So this is gonna be y to the second minus y, and you still have a 0 to 2 dy at the end. Are you following? And I'm gonna simplify 0 to 2, x third plus xy second, and then we have to subtract. So this part we have to finish. Y to the third, x is now, you're gonna plug in y into the x spot, y to the third, am I correct? Minus what? Y to the second minus y to the third, y to the second minus y times y to the second, because I'm literally plugging in this information into x. We are taking the integral with the dx. So this is something you're going to simplify, and we have still dy at the end. Okay, and then let's finish. 0 to 2, 2y to the third. Well, we need to simplify this one. So if you think about y to the second, this is a third time. Actually, we need to multiply this 3 times. Sorry. So that's what I'm going to do. So this one, y to the third, y to the fourth, y to the third, y to the third, plus y to the second. So y to the 4 minus 2y to the third, plus y to the second, and you have to multiply one more time. So y to the 6th, y to the 5th. So let me double check. Sorry. Y to the 6th, 2y to the 5th, y to the, I'm just using the distributive property, plus 2y to the 4, y to the third. Okay. Okay, let me combine in like term. Y to the 6th, 5 family, and 4 family, and 3 family. That's here. So I have y to the 6th, 3y to the 5th, 3y to the 4 minus y to the third. Sorry. So that's what happened. And we have this part plus y to the 4, y to the third. Okay, I got it. Okay, a little bit of work. Okay, and we have to keep simplifying before you're going to take the integral back to y. So I'm going to keep this one. Let me simplify everything inside. So 2y to the third, distributive property everywhere. So y 6 plus 3, 5, because we are doing the distributive property, minus 3y to the 4, and negative change to positive, y to the third, y to the fourth, y to the third. Am I okay? All right, combining like term one more time. We have a 6 family. So minus y to the 6th, the largest one. And then 5 family plus 3y to the 5th. And then 4 family here and here, minus 2y to the 4. And then 3 family, 2, 2. So this is going to be 0. So we have a 2 y to the third. Am I correct? dy. Is there anything that I made a mistake? I think this is correct so far, right? So I'm not doing any special. We have a y, right? So I think we are good. We are subtracting. So let me double check. So we have y, and I subtracting that. I think this is correct. Am I right? I'm pretty sure you're double checking with my work. Now the next one, finally. We are taking the integral with respect to y. I don't see nothing x there, so we just keep increasing. Y to the 7 over 7. 3, y to the 6 over 6. 2, 5. 2, this is how you're taking the integral from 0 to 2. So therefore, if I simplify, negative y 7, 7, simplify, y to the 6 over 2, 2 over 5, y to the 5th, 1 over 2, y to the 4 from 0 to 2. So basically now we're going to do the subtraction, minus 2 to the 7 over 7, 2 to the 6 over 2, 2 over 5, 2 to the 5th, 1 over 2, 2 to the 4. And then minus 0, because everything is going to be 0. So basically, you're going to calculate this one. I haven't not done yet. Now you can plug into the decimal. You will find out the decimal. That's going to be the region that we are looking for, this area. So this is a double integral because we have a two different, when we are given with the two different integrals. So this is a type 2 because x integral was a fixed. So just the calculation, it's a little bit long, but the concept is not that complicated. So I hope you guys okay so far. Okay, so I'm gonna hold up here. I'm gonna give you guys time to digest what is going on. Are you guys okay so far? I'm gonna do just one more example, okay? So 5.2, it's a very, very, very short topic. Nothing is complicated. Just they're gonna ask you, can you take double integral if I'm giving you the different boundary? So you have to define, the interval for each x and y, okay? I'm gonna hold up here. Are you guys okay? Double check. Can you show me your thumbs up? Okay, anybody has a question or are we good to go? All right, so one more example in terms of double integral. So you have a better confidence, getting better and better. So here we go, example 3. So in this question, we're gonna do both type 1 and type 2. So let's think about the question. So it's elliptic. So you have a given function. So f of x, y, x a second plus y second. So far, so good. And then we have to check what is going on. Y equal to x to the second, y equal to 2x. So this is the boundary, that gives you the hint to find out the x interval, y interval. But step 1, A, they want you to find out the type 1. So that means if I go up, type 1 set, x interval fixed. So we have to find out the x interval fixed. So x interval fixed, right? So in order to find out the x interval, this is the only information that I have. So it's a good news, y equal to x a second, y equal to 2x. So if you find out the intersection points, by solving for x, that's going to be your interval for the x-axis. Does it make sense? We did the same work. So since y equal to x a second, y equal to 2x, we're going to set it up that is equal to each other to find out what the x interval, because that's intersected. So x a second minus 2x equal to 0, x minus 2 equal to 0. So from here, I got it. One is a 0, another one is a 2. So 0 to 2, this is the fixed interval for x's. So very simple to find out the fixed one. So we have 0 to 2. So this is the fixed for the x interval. And then if you draw that line, y equal to x a second, this is the curvy. And then y equal to 2x. So if I draw better, y equal to 2x is going to be something here. And then you have y equal to x a second. So actually I need to write it better. So they're passing here. Y equal to 2x. And then y equal to x a second is going to be something. So they're exactly meeting here. 0,2 and 0,0. Does it make sense? Because that's the intersected point between those two functions. And then as you see, the x interval is a fixed. It's a linear. So this is the fixed interval. So that's why y interval is going to be changing. So if you look at that, the y interval is going to be changing. The height is going to be changing. So you are looking for actually this area. This is the area we are looking for. So type 1, I'm going to do type 2 later. So this one, I'm going to move letter B because I need a space. So anyway, let's continue. So type 1, let's continue type 1. So get rid of it. So the D, x, y, x is already fixed. So x is between 0 and 2. And you need to find out the y interval. What's going on? Y is already given. X a second, 2x. So compare which one is higher when you plug in the same number. If you're plugging in 1 is a 1. If you're plugging 1 is a 2. This is a higher. So obviously this is a 2x higher, x to the second. So this is your interval for type 1. We have all the information. Are you okay? So double I feel like double burger. Sorry, I'm hungry. But anyway, which one is a fixed? The x is a fixed, so we are putting the changing one inside. So this is the function, don't be confused. This is the function. And then this is a dy, right? Because this is changing, this is a fixed. Fixed is outside from 0 to 2. And then you have from x second to 2x. So this is what you're going to take. My dx is a little bit too far. So I'm going to bring here next. So now I know what to do, the inside one. Yeah. So if you consider the integral with respect to y, what did I told you? X is always constant. So that guy, we have a 0 to 2. X second is a constant. We're increasing the y variable. So it's going to be x second y to the third over 3. And then from x second to x. And then of course we have a dx at the end. I need to finish this part first. So this one, you're gonna plugging in 2x into the y spot because we are taking dy. So x second, 2x, 1 over 3, 2x to the third. This one minus x second. You're gonna plugging in x second, 1 over 3, x second, x to the second, yeah, to the third. So this is the inside, and you're gonna take the dx later. So if I simplify as much as I can, this is 2x to the third, 2 over 3, x to the third, and do the distributive property, minus x to the 4 minus 1 over 3, x to the 6. Now everything we are going to take the integral with respect to x. Are you happy? Yes. So now take the integral. Everything is x. Great. I don't see any y. So 2x to the 4 over 4. 2 over 3, x to the 4 over 4, right? X to the 5th over 5. 1 over 3, 7 over 7. From 0 to 2. Boom, 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 boom. Simplify. X to the 4 over 2. Cancel. X to the 4 over, this is going to be 2 times 3, 6. X to the 5th over 5. Minus x to the 7 over 21. Yeah? So it doesn't matter. You're going to just plugging in. So 2 to the 4 over 2. 2 to the 4 over 6. 2 to the 5th over 5 minus 2 to the 7 over 21. And 0, because this is everything 0. So I haven't calculated yet. You can plug in those fractions in decimal. You will get some number as a decimal. That's the region when you fix x interval. Are you okay with that? So we did type 1, but also we can solve type 2 at the same time. But I'm going to hold up here. Can you show me your thumbs up? Are you okay? So let me show you. So whatever the calculation decimal, you can calculate it, okay? So this is the same pattern, right? Just you need to, carefully read the question, find out the D interval for X and Y, okay? All right, let's do type 2. I'm gonna change the color. So let it be, let it be. You know what? I'm gonna just minimize it a little bit because I need always a space. Okay, let's do the B here. So in this time, I'm going to fix the interval for Y. So we type 1, we fixed X interval, right? But type 2, we're gonna fix the type 2. We are going to fix Y interval. Okay, so let's step by step. I'm gonna draw the same image because they're talking about the same region. So I'm gonna copy this. I'm gonna paste it here. Oopsie. So this is the information we have. We're looking for same region. So you know what? The answer is gonna be same because we are literally looking for the same region. just changing the order of the interval, whether you start taking the integral with respect to y or x, that's different order, but the answer should be same because we are looking for the same region with the same given information. So in this time, since we are looking for the fixed y, here is the thing. So go up here. We have y equal to x to the second, y equal to 2x. And then, you know what? Here we go. We have y equal to x to the second, and we have y equal to, what was it? 2x. I'm gonna change this one in terms of the x variable. So what I'm saying is, if you remember calculus 1 and 2, if you rotate y-axis, x-axis, you have to change the function in terms of the other opposite variable. So what I'm saying is, this equation was a solve for y, because y equal to something. I'm gonna solve for x. So if you solve for x, what happened? This equation will be x equal to, you're gonna put the square root both of sides. So it is gonna be radical y. So this is the same equivalent equation, just different perspective, whether you're gonna solve for y or whether you're gonna solve for x. So based on the equation, I can find out x equal to radical y. They're same like a graph, okay? Okay, now, so y equal to x a second. So I'm gonna change this one. This curve has another name, x equal to radical y. Okay, so far so good. Also, I'm gonna solve for x for the second equation. X will be 1 over 2y, right? So this is linear line has another name, x equal to 1 over 2y. Now what happened? To find out fixed y interval, these two equations gonna be equal. So these two are gonna be equal. Because I wanna find out the fixed y. Watch me, so what happened? Radical y equal to 1 over 2y. We can create this equation. Yes? Because each one is x. And now I'm going to square root on both of sides. So y, 1 over 2y to the second. So y, 1 over 4y to the second. Are we okay? Okay, now let's solve for y. So I'm gonna just multiply 4, both of sides, and then y second minus 4y equal to 0. So what happened? We got everything here. Y minus 4 equal to 0. So y equal to 0, y equal to 4. This is the fixed interval for y. We got it. Nothing is special, just, I mean, you don't need to do this work because it's gonna be the same answer anyway, but I wanna show you both way, type 1 and type 2, for the same question, it should be the same answer because it's the same region they're talking about. So this is what's happening, right? We are solving for x to find out the interval for y. So this is the interval for y. So therefore, this is a type 2, the region. We have a fixed y between where? 0 to 4. And then this is your interval for y. So plugging in 1, if I plugging in 1, it's 1, it's gonna be 1 over 2. So this is a smaller one. So you have to plugging in 1 over 2y and radical y out, the large one. So this is the interval. Now we got it. So we're gonna use the given function was what? This one. So let's take the double integral. So the changing one is here. So I'm gonna plug in x second plus y second, dx first, and then dy was a fixed 0 to 4. And then here, 1 over 2y radical y. So let's see, okay? You're gonna take the integral with respect to x. So y will be constant, x to the third, increasing x from 1 over 2y radical y. So I'm gonna keep finishing. Radical y to the third, because you're plugging in this into x. Radical y to the second, minus, you're gonna plugging in 1 over 2y. I know this is a little bit ugly, but that's what it is. You're gonna plugging in 1 over 2y, y to the second. So we're going to subtract that, but we know still we need to take the integral with the dy at the end. So I'm going to just simplify. So this means 1 over 3, I'm going to just y, this is a 2 over 3. So that's a radical half times the 3. Oh, I have a little typo. So this is 1 over 2, 3 over 2. Plus, this is a y half, you can adding them, y to the 5 over 2. So you're adding 1 over 2 plus 2. So it should be 5 over 2 minus, so this one, 1 over 8y to the third, you divided by 3. So that means 1 over 8y to the third times 1 over 3. So you should get minus 1 over 24y to the third. And then do the distributive property, 1 over 2, y to the third. That's it. That's our first integral, and then you have to do 4. So actually, this one, 1 over 3, y, and you divide it by that exponent, right? That's a step-by-step work, but we know what is going on. Y4 over 4, 1 over 2, y4 over 4, from 0 to 4. So let me just organize it. So 1 over 3, I can bring this one up, flipping over. I can flip over 2 over 7, 7 over 2. And then I can multiply 96, y to the 4, 1 over 8, y to the 4. And then from 0 to 4. So basically, you're going to plugging in 4 into y, and just use the decimal. You should get the same answer with the type 1 and type 2. Type 1 and type 2 should be the same answer. But this is the idea how you're going to take the double integral, type 1 and 2. Okay, so that's it. That's the 5.2 main idea. So you can check it out by calculating yourself later. But just I want to give you that idea. Doesn't matter, it's going to be the same answer, right? Because it's same region. Okay, I'm almost done. So I'm going to do the last concept of the double integral, the property. So the last concept is very short, as I mentioned. Can I go to the next slide if you guys okay? Anybody has a question? So the calculation, you can practice though. This is not really complicated work, but check it out. You're actually getting the same answer though, okay? All right, so last 3 more slides. Here we go. The property everywhere. You will find out the property for limit, differentiation, integral everywhere. So same thing for the double integral property. Same thing. If you have addition, subtraction, you can sum together, adding together, subtracting together, or you can separate it because of the distributive property, correct? You can, separate it. So that's a sum and difference. Constant, you can bring it to the front, right? That's a constant. And then as you know, you can use a squeeze theorem. If there's a specific order, the integral also will be the same order. If the f function is smaller than g, taking the integral will be the same order. The taking integral of the f is going to be smaller than g. So this is a squeeze theorem all the time, everywhere. And then number 4, okay? So this one is a little bit interesting. So if D, okay, you are combining 2 different regions where D1 and D2 do not overlap. So let's say, the Venn diagram. Let's say I have A and B. This Venn diagram, and I have this Venn diagram. What is the difference between 2? This is no common area. This is a sharing. There's a common area. So what I'm saying is, if D1 and D2, they don't overlap anything each other. So you have D1 area, you have a D2 area, they're nothing sharing. You can separately adding, and then it's going to be same answer, D1 and D2. That's what that means, okay? And then number 5, the area of the region. So just this is like a little bit probability, but I'm gonna skip this one. It's not really always happening. Okay, just skip that one. Usually it's a true for the probability, but our textbook, I don't think we're not really emphasizing on, but just, you know, the total area is 1, okay? The 6 is actually more important. So the same thing, if the squeeze theorem, this is between M and M, like there's a minimum, there's a maximum. If you have like, you know, there's a function between them, the integral is gonna be the same thing, double integral, okay? So the order is gonna be the same thing. So number 3 and 6 definitely squeeze theorem. Okay, so we're gonna apply this one into the next question example. Okay, so let me take a look at the next example. Here we go. So I'm giving a little bit complicated function. Ooh, e to the x second plus y to the second. And then they say this is gonna be the disk shape. The region of that you're looking for is a disk. And then is a region center, origin, and then let's imagine center is a 0, 0 origin. Radius is a 2, no matter where you're going up and down, north and south, east and west. This is a circle equation. We know how to write it. This equation, circle x second, y second, r to the second. So radius is a given. So this function is talking about x to the second, y to the second equal to 4. This is going to help us to find out the integral. This is the integral hint, okay? So we can get it. And then this is actually given function we are going to take the integral. So we have to think about it. I want to take the integral, right? So the fact of the circle equation, x second plus y second, and then we are looking for the region. It's going to be less than or equal to 4. So this is the for sure. You can find out by reading the circle equation. Now we are taking the integral of this one. And then you think that something is a common x second plus y second. Here, x second plus y second. So what if we are doing this one? So the region of the circle, it should be positive number. So this is something you can find out. We're going to start from here. So we do have this equation. And you know what? What if I take e everywhere? E to the 0, e to the x to the second, e to the 4, according to the squeeze theorem. If this order is true, this order should be true too, correct? So what happened? This is going to be 1, e to the 0 is 1. And now we are getting close to the equation that we are looking for, e to the 4. And now we are taking the double integral. So now I'm going to keep on taking double integral everywhere. So what happened? If you can find out one of the answer, the first and last answer, you can find out the middle automatically. So you don't need to do any complicated work. Just keep using squeeze theorem, right? So just follow your logic. Almost done. So what happened? I'm going to just take the integral, right? So I'm going to take the integral. So we do have, what happened? So the integral, we have, there's a 0, 1, there's a x sec. Actually, I have, when I look at this textbook, there's no information for this. So I'm going to get rid of it. So this is not given. Okay, that's it. That's it. Nothing is special. So we don't have like specific information for the D, but we know we're looking for the D, the region of that. So hold up there. Hold up there. What are you guys going to do? Are you going to stop here, or we know the area of this circle formula is a pi r to the second. And actually we know the area. Pi 2 to the second, it's a 4 pi. Okay, so if it is a 1, that means the original like the circle equation. So basically we are going to multiply 4 everywhere. So this is going to be 4 pi. And then e to the x second, y to the second. And then this is a dA. This is going to be same as 4 e to the 4 pi. Or you can change 4 pi e to the 4. So what I'm saying is, we don't know exactly what the area of this, but it's going to be between 4 pi and 4 pi times e to the 4, because the circle equation is 4 pi. We just know this is a fact, but then we don't know the information here. So it's going to be a little bit plus minus arrow. That's e to the 4. So we believe that the actual reason that we're looking for, it's going to be between 4 pi and 4 pi times e to the 4. So that's the conclusion. Okay, just check this information. So this is the one of the question we are using the squeeze theorem. Okay, so I'm going to quickly hold up here. Are you guys okay with that? Okay, if anybody has a question, let me know, or not. We're gonna move on to the last question. Okay, let's go to the last question. All right, here we go. So this is the last question. Well, you already saw this in calculus 2, the average function. So if you remember, if the function is integrable, there is no hole in break over the plane, and there's a region, and then you can also find out the average value of that function. So what I'm saying is, if you remember just one variable, a to b, so we know a, b, f of x, dx. This is the area. I want to find out the average. There's some number that gives you the average value of that function. So if you want to find out, we used to multiply b minus a at the end, at the first, in front, and then you can find out the average value of the function. So we are using the same thing. I want to find out, so we are having a double integral. I don't know, like, let's say we have like this shape. I want to find out the average value of this. From A to B, we have a more complicated, two different, C and D. I want to find out like some average value, of this particular function with two variables. So the formula is, you're going to find out the area of that, half of it, and times the double integral. Same thing what you learn in calculus 2. So I will just show you an example. That's a better, rather than memorizing it. So we do have, this is the given function, y equal to x. And then this is going to be the triangle region by pointing those two, by pointing those three. So 0, 0 right there, 0, 2 right there, 2, 2 right there. So something is going on. This is the area. I want to find out the average, average value of this function, and what is that information. So that's just, abstract concept, but you can find out the average from here, average from here, average from here. So this is formula going to tell you how to do it. The function average. So we can find out the area of this triangle because everything is a linear line. From here, here to, from here, here to. So the area of this triangle will be 2 times 2 divided by 2, gotcha, 2. So the area of this region is already 2. So 1 over area, double integral, the function is y minus x, and we do have dA. It doesn't matter which one you want to do first, dx or dy. So it is going to be ff and then y minus x. I want to do dy first and dx later. So what is a y variable? From this is y variable, and then the x variable from here, but we have to be careful a little bit because this is a y equal to x. If you look at this line, This is y equal to x. And then this is the inside, so it's a changing. So what I'm saying is x is fixed. So x is gonna be anyway 0 to 2, correct? So x 0 to 2. And then if you fix the x, dy is a changing, one of them should be variable. You have to use a variable. So what I'm saying is it's gonna be 0 to 2, but you have to changing. Something is a changing, as x is changing, y is a changing. So actually this is a better interval, x to 2. As x is changing, you're keep up, and stop at 2. So we are going to write that way. So this is your interval. So we're gonna take the integral inside this part. So take the integral with respect to y. So y to the second over 2. X is a constant from x to 2. And we have a 0 to 2 dx and 1 over 2 in the front. So this part, 2 to the second over 2, you're gonna plugging in 2 into y. So 2x and minus x to the second over 2 minus x to the second. So this is inside 0 to 2 dx, we have a 1 over 2. Almost done. I'm gonna do all the distributive property. So this is going to be 4, right? So 4 divided by 2 is actually 2, my bad. 2 minus 2x minus x to the second over 2 plus x a second. Then we are taking the integral with the respect to x. So 2x minus 2x a second over 2, 1 over 2, 3 over 3, x to the third over 3. Okay, a lot, but we can handle it. 1 over 2 in the front. So if you calculate it, everything is a 0 for the second term, but the first term, 2 times 2, 2 to the second over 2, 1 over 6, 2 to the third, 2 to the third over 3, and minus a 0 is a 0. So 1 over 2, 4, cancel 4, 8, so this is 8 over 6, this is 8 over 3. So cancel 0. What happened? If you calculate it, 1 over 2, negative 8 over 6, I'm multiplying 2, 16 over 6. So 1 over 2. I have a typo. There's a positive, it should be positive. So that if I calculate it, it should be positive 12 over 6. So if I cancel, that's a 6. Am I correct? So let me just double check the calculation because that one was a positive, but I put the negative. So we have 8 over 6, which is a 4 over 3. And then I do have x to third over 3. And then 8 over 3. So this is a 6. I have a 1. That's the area. So I think I don't see any mistake, but you can double check. So this is the point. Okay. This is average of this double integral. The average is going to be 1. Okay. So I don't want to really emphasize on this question.
Excuse me.
Yes. Is there any mistake do I have?
Oh, I cannot hear you. Hello?
Yes, I hear you.
The last step, sorry, my headphone has problem. Let me take it off.
Go ahead.
The last step, you change 12 to over 6 to 6 over 6.
Mm-hmm. Oh, wait, yeah, you're right. This is the 8.
Yeah.
Yeah, sorry about that. Sorry, I was like rushing. So 8 over 6. Yeah, so it's going to be 4 over 6. Yeah, 2 over 3. This is the average value. Okay, so think about it. But, you know, this is a more physical question. So later, if you're taking other advanced physics class, they might be looking for like average velocity, average speed. That's where we are looking for the double integral. So like a one interval for the, you know, speed, another interval for the distance. So they're keep changing the interval. So in that time, the x, y, z, whatever multiple variable gonna be represented by like distance, speed, or the time. But this is just fundamental idea how to take the double integral. So I mean, I don't really want to emphasize on this question, but think about it. If you're planning to take any other applicational math or physics in the future, this might be helpful. This skill might be helpful. So like later, what I'm saying is in the future math, after calculus 3, there's like the integral. There's a function. So I don't know if you want to get a, Mars in the future. One is going to be like the time, t1 and t2. Another interval is going to be distance. You have to keep taking the integral, time, distance. It could be speed, velocity. You could add many variables depending on the context. But what I'm saying is calculus 3, we are just focusing on double integral, but you can expand this knowledge in the future if you need more, okay? So same thing like the average, you can find out the average time, you can find out the average distance. So this concept should be more applicable in the application problem in physics, okay? But physics and math is very relevant to each other, as you know, so that in calculus 1 to 3, we are focusing on how to take the integral, how to take the differentiation, how to take the double thing, like by increasing the variable, so that using this technique and skill, you can apply into engineering subject or physics subject in many areas or in finance. So I just want to, that's why math, many people call that it's a fundamental skill, so that I'm helping you guys to understand the basic, fundamental skills in math. Okay, so I think that's it. We finished at 5.2. So if you need more practice, go back to our textbook. There's a free textbook in our module. Check it out, and there are more reading stuff and practice. And also we have embedded video in each quiz that would be really helpful. Okay, so next session, in next video, we are going to move on 5.3. We're gonna keep using this skill, double integral. Okay. I will stop recording at this moment. I will see you guys soon. Thank you, everyone. Bye-bye.